All right, so today we're having to change two equations in order to get opposite coefficients. So whenever we're graphing, we just have to get y by itself to graph the equations. Whenever we're doing substitution, we just have to get one of the variables by itself to plug it in. When we're doing elimination, we have to get opposite coefficients for one of the variables. Does it have to be x? No, it can be x, it can be y. It doesn't matter. So right here we have 4x plus 3y is equal to 8. And 3x minus 5y is equal to negative 23. So we have 4x and 3x. We have 3y and negative 5y. Okay? So we can change either of these. I don't care. Harrison, do you have a preference? Okay. So do you have a preference on if we cancel out the x's or the y's? You don't care? Tyler, x's? Okay, so if we want to change and get rid of the x's, we have a 4x and a 3x. We have to get these to have the same variable, just opposite, or same coefficient, just opposite signs. So if we have a 4 and a 3, what can they both go into? 12, okay? So 4 times what is 12? 4 times 3 is 12. 3 times what is 12? 4. And one of these has to be made into a negative. Which one would y'all like to do? The negative? No, so you want to multiply by negative 3 here?
No.
Or you want to change this one?
Yes.
Okay. Does it matter? No. Okay. When we multiply one of these equations, we have to multiply everything in the equation. 3 times 4x is 12x. Plus 3 times 3y is 9y. Is equal to 3 times 8 is 24. So all we have done, we have not changed the value of anything. We've just multiplied all the coefficients by 3. And on the other one, we're going to multiply all the coefficients by negative 4. Negative 4 times 3x is a negative 12x. Negative 4 times a minus 5y gives us a positive 20y. And a minus 4, negative 4 times a negative 23 is a positive 92. Okay? So the whole purpose of elimination is to get opposite coefficients for one of the variables. Y'all chose x, and y'all chose to make this bottom one negative. Y'all could have made the top one negative. It didn't matter. Okay? So I'm going to go... Do y'all want me to rewrite it, or are y'all okay with just solving it? Okay. So what we're going to do is we're going to combine these two equations then to end up getting rid of that x. So 12x minus 12x is 0 x's. Do I need to write down an x? No, because there are no more there. 9y plus 20y is 29y. 29y is equal to 24 plus 92. Very good, guys. Okay, so we ended up getting rid of a variable, so this way we can solve for y.
Miss Cornell, if it's not like x and y, like it's a and b, then how do you know which one's x and which one's stands for y?
It doesn't matter. Okay, so when we divide by 29, what did y'all get for y?
4.
So y is equal to 4. Okay. So now that we have y, we still have to find what x is equal to. And in order to find what x is, we just have to pick one of our original equations. Are y'all good with the top one? Because it's all positives. It's prettier. So on this top equation, I'm going to do 4x plus 3. This says 3y. What do we know y is, though? 4. So we're going to replace that y. Tyler? We're going to replace that y with 4. So 3 times 4 is equal to 8. That way, we only have x in our equation this time. So we can solve for x. Questions? Okay. 4x plus 12 is equal to 8. What, Shefton? All right, minus 12. What's 8 minus 12? Okay, very good. So when we solve for x, we should get x is equal to -1. And then what form do I need to put this in? A coordinate. And what always comes first in a coordinate? X. -1 comes first. 4 comes second. So this is our solution. And if we graphed these lines, they would cross at this point. Okay, that's their common solution, their common point. No. Okay? Yes. Okay, any questions on example 3? Okay. So let's go ahead and look at our practice problem. We have 5x minus 3y equals 6. And we have 2x plus 5y is equal to -10. Okay? We will have to change both of these equations in order to get a common coefficient. How many of y'all want to get the same coefficient for x? How many of y'all want to get a common coefficient for y? How many? Okay, y. All right. No, I want y'all to do it both ways. Okay, I want some of y'all to do x and I want some of y'all to do y. Okay? So at least I can count on Gavin to get y, right? Okay, so I want you guys to go ahead and get a coefficient the same. I don't care if it's x, I don't care if it's y. I want y'all to both, or all of y'all to do something different so we can look at both options, okay? Alright, so on this side, I got my x's to cancel out. Okay, so I got them to get opposite coefficients. So I multiplied this top one by 2, the bottom one by -5. So that way I got a positive 10x and a negative 10x. Okay, positive 10x, negative 10x goes away. And then when I combine these, I got a -31y is equal to a positive 62. So I just added my equation. So y's with y's, constants with constants. I divided by -31 and got y is equal to -2. And then when I plugged it back into one of the original equations, it doesn't matter which original equation you use. When I plugged it back in, I got x is equal to 0. So here I got a positive 10x and a negative 10x. On the other one, you only had to multiply by positive since your y's were already opposite signs. So since I had a -3y and a positive 5y, they both go into 15. So I multiplied by 5 and 3 and got a -15y and a positive 15y. So that got rid of that, and I got 31x is equal to 0. So x is equal to 0. Plug that back in to get y, which was -2. Okay? Do I need to go over anything a little bit more clearly? No? Jacob, you're squinting at the board. What does that mean? You need glasses. Yeah, I'd say so. Did you cancel out your y's? For your x's? Or did you do nothing? You did some. Okay, so did you cancel out your y's or your x's?
My x's, but I did it wrong.
You x's and you did it wrong. Okay, so let's look at our x's. Did you get opposite signs for your x's?
Yes.
Yes. Did you do 2 and -5?
Yes.
Okay, so when you multiply by 2, did you get 10x minus 6y is equal to 12? 10x minus 6y is equal to 12. Okay, so we got to make sure we distribute to each and every one of those terms.
Yes, I did.
Did we forget one?
Mm-hmm. That's why I missed it.
Yeah.
No.
Okay. Anybody else? All right. Then let's look at our word problem then. So on our word problem, we have a hardware store earned $956.50 from renting ladders and power tools last week. The store charged customers for a total of 36 days for ladders. Okay, so 36 days for ladders, 85 days for power tools. This week, the store charged 36 days for ladders, 70 days for power tools, and earned $829 compared to that $956.50. How much does the store charge per day for ladders and per day for power tools? So what are our two variables going to be?
X and Y.
Okay, X and Y. But what do they represent?
Ladders and power tools.
Ladders and power tools. Which one do you want to be ladders?
I wanted the power tools.
Okay. X is power tools, which means Y is ladders. Doesn't matter? Nope, just pick one. Okay? So X is power tools. So our first equation is going to be dealing with that first week, okay? That first week, how many power tools, how many days did they rent out power tools? Power tools. 85. 85 for power tools. So 85 what? X. They also, which means plus, rented out 36 days of ladders. So 36Y. And their total came to?
$956.50.
Very good. 956.50. Then our second equation is going to be that second week. So 36 days for ladders and 70 days for power tools. So I'm going to do power tools first. So 70x plus what?
36Y.
Good. 36y is equal to 829. Okay, so what would be the easiest thing to do and get rid of? Okay, multiply by a -1. On both or one? Just on one. Because what's already going to be easily to get rid of? That y. That's 36y. Okay? So I'll let you guys do that and solve this problem. Setting it up is usually y'all's main struggle.